Lesson 11, Measuring Variability. So variability, we've heard this word before, it's how spread out the data is. And there are a few different ways to measure it. In this lesson, we're going to look at how we can use the interquartile range as a measurement of variability. So we're going to remember from previous notes that you calculate the interquartile range, or IQR, by doing Q3 minus Q1. So first what you're going to do, this is a problem from the book, page 76, but we're going to do it here in our notes. So each box plot summarizes the number of miles driven each day for the 30 days in each month. And we're going to figure out the median and the IQR for each. And then we're going to answer this question. And then we're going to rank them. Which month had the most variability in number of miles driven per day? Okay, let's start with August. The median. So if you remember box plots, the median is that bar in the middle of the box. So the median is 40 miles. That's the middle number of miles driven in the month of August. And the IQR, we have to do Q3 minus Q1. So remember, Q3 is the right end of the box. Q1 is the left end of the box. And to find the IQR, we just subtract them. So in this case, it's 60 minus 20, which equals 40. It happens to be the same here. That's not always the case. Let's try this one. The median is also 40. The IQR is going to be 70 minus 10, so it's 60 interquartile range. So go ahead and do that here for these other ones. And I'm just going to do that quickly here. So pause the video and do it on your own, and then you can resume and check your answers. This one also has a median of 40, and IQR is 50. This one has a median of also 40. IQR is 70 minus 30, 40. This one has a median also of 40. IQR is 50 minus 30. That is 20. All right, the next column asks us, why is the median more appropriate for finding the center of this data set than the mean? And as we learned from lesson 10, when you have a data set that is not symmetric, that's skewed or has some big outliers, the median's the better measure of center. So we can just say it's the best measure because it is not symmetric. Oops. And actually, that's the case for all of the months here. None of these have an exactly symmetric distribution. Okay, now we're going to go to ranking them. Which month had the least variability and which month had the most? And we are going to use IQR. So the smaller this little box here, the lower the variability. That means there's a lot of values clustered around 40, around the median, right? 50%, the box represents 50% of the data points, are between, in this case, 30 miles per day and 50 miles per day. So this one has the least variability. That's rank number 1. Let's see, which has the most variability? This one here is the most spread out. Let's maybe use a different color here. Let's try blue. Okay, so this is the biggest interquartile range, 60, the biggest interquartile range, meaning that 50% of the days are spread out over between 10 miles driven per day and 70 miles driven per day. That's a lot of variability, so that's going to be our 5th one. And then we have to rank the other ones. Let's see. This has the next biggest IQR, so that's pretty variable. That's going to be 4th. Pause this for a minute and then see what you think for the other ones. Okay, these other two have the same IQR, 40 and 40. So we have to decide if it has the same IQR, what could we go to for variability? Well, it looks like here the minimum is 10 and the maximum is 80. That is more spread out, we call that the range, than this one, the minimum being 5 and the maximum being 60. So this one is actually more spread out, so that would be the third, and then this would be the second most variable. So 5 being the most variable and 1 being the least variable. Those are our rankings. Okay. And let's complete this statement. Pause the video, see if you can complete it. The larger the IQR, the greater the variability of a data set. So it's an easy way to calculate very quickly and compare one set to another, the variability. Okay, what if two sets have the same IQR? That's what we did above here, where they both had the IQR of 40. So pause and fill this in. The top box plot, what is the median? Well, it looks like it's 9. The bottom box plot median is also 9. And the IQR is, it looks like 13 down to 8. So IQR is 13 minus 8, which equals 5. And it's the same for both of them. So in this case, if it has the same IQR, then you have to look at the range. You have to look at how big is the span from minimum to maximum. And the bottom one has the bigger span from minimum to maximum, the bigger range. So the bottom has the greater variability. Standard deviation we're going to do the next